Join me as I try to defy gravity using quantum levitation and see if I can make some amazing magic happen. Today, we're diving into the fascinating world of quantum levitation, a phenomenon that seems like magic, but is rooted in the laws of quantum mechanics. It's a concept that has captivated scientists and enthusiasts alike, and I'm excited to share it with you. Gravity is one of the most fundamental forces in our universe, governing the behavior of objects from the smallest subatomic particles to the largest galaxies. However, traditional physics struggles to fully explain certain aspects of gravity, particularly at the quantum level. This is where the principles of quantum mechanics come into play, offering a new perspective on the nature of gravity and its interactions. The challenge of understanding gravity lies in its complexity, with many theories attempting to explain its behavior. However, these theories often contradict each other, leaving scientists puzzled. For instance, Einstein's theory of general relativity revolutionized our understanding of gravity, but it's incompatible with the principles of quantum mechanics. This disconnect has led scientists to explore new approaches to understanding gravity, including the study of quantum levitation. In recent years, scientists have made groundbreaking discoveries about the properties of superconductors, which have led to a deeper understanding of quantum levitation. Superconductors are materials that can conduct electricity with zero resistance, and under certain conditions, they can also exhibit quantum levitation. This phenomenon allows objects to float in midair, defying the conventional laws of gravity. So how does it work? When a superconductor is cooled to extremely low temperatures, it creates a thin layer of electrons on its surface. This layer, known as a Meissner field, is capable of expelling magnetic fields, allowing the superconductor to levitate above a magnetic track. The resulting effect is a frictionless, gravity-defying phenomenon that has the potential to revolutionize various industries, from transportation to medicine. To illustrate this concept, let's take a look at a stunning demonstration of quantum levitation in action. Watch as this superconductor is cooled to its critical temperature and levitates above the magnetic track. The visualization of the magnetic fields and the flow of electrons creates a mesmerizing display of quantum mechanics at work. As we observe this phenomenon, it's essential to understand the underlying science driving it. The quantum levitation effect is a result of the superconductor's ability to create a stable equilibrium with the magnetic field, allowing it to maintain its levitated state. This equilibrium is a delicate balance of forces, with the magnetic field pushing the superconductor upward while the weight of the object pulls it downward. The implications of quantum levitation are far-reaching, with potential applications in fields like materials science, engineering, and even space exploration. Imagine a future where vehicles can travel at incredible speeds, using quantum levitation to reduce friction and increase efficiency. In conclusion, quantum levitation is a remarkable phenomenon that showcases the power of quantum mechanics. By defying gravity, we're not only pushing the boundaries of scientific understanding, but also unlocking new possibilities for innovation and discovery. What do you think about quantum levitation? Share your thoughts in the comments below. And if you want to dive deeper into the world of quantum mechanics, be sure to check out our next video, where we'll explore more mind-bending concepts that will leave you wondering about the nature of reality.